Alright, in this video, we are going to start our mole conversions. Okay, you are going to need your mole map, and you are also going to need a periodic table. So let's start talking about our mole conversions, and then we're going to get into our first conversion today, which is the mole mass conversions. So there are three mole equalities. They are 1 mole is equal to 6.02 times 10 to the 23rd particles. 1 mole is equal to the molar mass, which is found on the periodic table. And 1 mole is equal to 22.4 liters for a gas at STP. Okay, STP stands for standard temperature and pressure. Now, these three mole equalities here that you see highlighted, those three correspond to the three parts of our mole map. So we have mass, we have particles, and we have volume. So each equality can be written as a set of two conversion factors, okay? And those are seen here, okay? All of these correspond to the arrows between each of these conversions. So there is a general method of solving these problems, and you can see the steps there below. Okay, first thing you want to do is determine what are you solving for. Is it asking for grams, moles, particles, atoms, liters? Okay, always start with what you know. Start with the number that is given to you. Create a conversion factor based on what you are solving for and what you are starting with. Okay? So if you go to your mole map, if you're given moles and you're asked to find the mass, then you're going to take your finger and go from mole town to mass mole, and this is the conversion factor that you're going to use. And I'll show you what it's going to look like in a little bit. If you're going from mass mole and it asked you to find the moles, then you would use this conversion factor here. Okay, in that second fraction, in that conversion, place your labels so that the bottom label will cancel out with the top. Okay, remember, you're trying to cancel out units so that the one you are looking for is the only one that remains. Okay, once you cancel your labels, you can then input the numbers into your calculator and get your answer. Okay, so let's look at an example using each of those different steps. So the question says you are massing a 24 karat gold chain and find that it weighs 400 grams. Determine how many moles of gold atoms you have. Okay, so first we got to figure out what are we solving for. Well, it says determine how many moles. So we know we have to get to moles. Step 2 said to figure out what are you given. Well, it says in the problem it weighs 400 grams. So we know the mass of it. That is what you're going to start with. That is what you are going to write down first. Now, we're given mass and we have to get to moles. So let's look at our mole map to figure out what our conversion factor needs to be. Okay, we're given mass and we need to get to moles. So I'm going to go from mass to moles and look at this arrow, because remember, it only goes in one direction, and you're going to use this conversion factor, 1 mole divided by the molar mass, which is going to be in grams. Okay, well, what molar mass do I need? Well, I'm dealing with gold. So I look at my periodic table, and I can find AU, and it is about 197 grams. Okay, you can be more exact and put 196.97 if you'd like. So I know that 1 mole equals 197 grams. Okay, this is my conversion factor. And as you can see in step 4, I put 1 mole on the top divided by 197 grams. this is exactly what it's said to do here, according to my mole map. You're always going to be able to use this mole map. So we can now set up our whole problem. Okay, we start with our 400 grams. We're going to multiply it by our conversion factor, which is 1 mole divided by 197 grams. And I've set it up this way so that my grams will cancel, leaving me only moles at the top. Then I would go to my calculator, and just like the other dimensional analysis problems, you take whatever number is on top and multiply, and whatever number is on the bottom and you divide. So I would put in my calculator 400 times 1 divided by 197, which we can see here. If I put that in my calculator, I get 2.03 moles of gold, or AU. Okay, so this is how we can use the mole map to figure out any conversion between each of these units. Okay, now for today's problems, we're going to stick with the conversions between mass and moles. Okay, so we're only going to use this upper left-hand corner of our mole map. Okay, so if you go to the second page, we have our mole mass conversions. You can see that the first example has been done for you. Okay, so let's take a look at it, and then we'll do another one together, and then we'll do the rest on your own. So the example says, how many moles are in 28 grams of CO2, carbon dioxide? Okay, well, let's consider the steps from before. We have to figure out, what are we given? What are we trying to figure out? Okay, well, the question says, how many moles? Okay, so that is my end point. That is what I need to finish with. And it says 28 grams of carbon dioxide. That is the number, that is the unit that I am starting with. So if I have 28 grams, that means I'm going to start with mass. So if I look at my mole map, I have mass, and it's asking me to get to moles. So I'm going to go from mass small, take this arrow, and go to Moletown. And I'm going to use this conversion factor, 1 mole divided by molar mass. Okay? Now, I need to find the molar mass of carbon dioxide. Okay? To find the molar mass of carbon dioxide, I figure out how many atoms of each element I have. So I have 1 carbon, and I have 2 oxygens. Then I need to find the molar mass of each element, and I find that by going to a periodic table. So carbon is 12.01, oxygen is 15.99. You can round that up and use 16 as oxygen. I will allow you to do that. One thing to note, molar masses are usually given in 2 decimal places. So even though, for example, carbon is 12.011, starting to get into the habit of only putting 2 decimal places, so 12.01. So I multiply my element's atomic mass by however many I have. I have 1 carbon and 2 oxygens. So 1 carbon times 12.01 is 12.01 grams per mole. And 2 oxygens times 16 grams is 32 grams per mole. And to find the molar mass of carbon dioxide, I add up my 2 totals to get the overall molar mass, which is 44.01. Okay, so that is the number I'm going to have to use. So now let's set up our conversion factor. We have 28 grams. That's my starting point. We have to multiply it by our conversion factor. Remember, if we go back to our mole map, it says 1 mole divided by molar mass. So I have 1 mole on top, and I have the molar mass, which is 44.01 on the bottom. Now you can see how the grams will cancel. Okay? The math in your calculator, you would take 28 times 1 divided by 44.01. Since we're multiplying by 1, you don't need to do that step in your calculator. So all you have to do is 28 divided by 44.01. Put that in your calculator and you get 0.64 moles of CO2, carbon dioxide. Okay? If you follow the mole map, it tells you exactly what to do. Okay? You just have to figure out what you are given and what you are trying to find, what you're trying to get to. Okay? Remember, for these problems, you are only using this side of the mole map. Okay? Because we're going between mass and moles, you're only going to be dealing with this for now. Okay? Why don't we do number 1 together? Okay, so number 1 says find the number of grams in 0.5 moles of Fe2O3. Okay, so first thing to figure out is, what am I looking for? Well, it says find the number of grams. Okay, so I'm looking for the mass. Okay, well, what am I given? I'm given 0.5 moles. So I'm starting with moles and I'm trying to find mass. Okay, let's check our mole map. I'm given moles, so I'm going to start in Moletown. And I'm going to try to get to mass small. And in order to do that, I follow the arrow, right? The arrow that's going up and to the left. And the conversion factor it says to use is molar mass divided by 1 mole. Okay, so let's go ahead and try to lay this out. Now, one thing you can do if you want to do this on the computer, if you don't feel like printing out this paper or writing out on a separate sheet of paper, is you can copy this example that's already done here. And if you copy paste it, we can now go in and just plug in our numbers. Okay, so I'm going to show you how that works. So I am starting with 0.5 moles. Okay, MOL is a shorthand way that you will see moles be written. That's usually the way that I will do it. Okay, so 0.5 moles. Okay, I want to check my mole map. Okay, I'm going with moles to mass. I need to put molar mass on the top and 1 mole on the bottom. Okay, so I can put 1 mole on the bottom and I need the molar mass. But what molar mass do I use? Well, I have to look at my compound. It says I'm using Fe2O3, iron 3 oxide. Okay, so I need to figure out, well, what is my molar mass of Fe2O3? Okay, now you can go ahead and type this out, or you can just do this on your own. Okay, I have 2 Fe's. And if I look at iron on my periodic table, it is 55.845, so 55.85. And I can add that to 3 O's. You know, I'm going to put these in parentheses to make it very clear for you, because we're going to end up adding these together. 3 O's, which if you remember, oxygen is 15.999, and we can use 16.00. So if I go and put this into my calculator, all right, I could do 2 times 55.85. That is 111.7. And I'm going to add that to 3 times 16. So altogether, you have 159.7 grams per mole. So this number, the 159.7, is grams. Here's the 1 mole. Grams divided by mole. Okay, so I'm going to erase the previous answer. And now I can see I have moles on the top, moles on the bottom. Those will divide, those will cancel out. So the math that I want to do is 0.5 times 159.7. Okay, so I have the 159.7. I'm going to multiply it by 0.5. And I get 79.85 grams. Okay, 79.85 grams. And just so we are clear, I'm going to box my answer. Okay, make it very clear what my answer is. Okay, 79.85 grams. You have a couple of examples here. You have the one we just did together. You have the example right here. And you have the example on the first page. Okay, I want you to try to do the rest of these problems. Okay, you are only going to use, remember, the mole and mass conversions. Okay, so these are the only two conversions you are going to use. Think about what you are given and what you are looking for. Okay, set up your conversions so that one of your units will cancel. If you do this correctly, one of those units will cancel, and the only unit left over will be the one that you are looking for.